All right. So this is the differential equation packet. And first it says the general solution to the differential equation. And so to find the general solution, we do like our separable equations and we solve for y. So I divided the y squared over here. So I said I had 1 over y squared dy. And then I left the sine x over here and I moved the dx over. And then you integrate each side. So 1 over y squared is really the integral of y to the negative 2. So if I add 1 and divide by negative 1, I get negative y to the negative 1. And then the integral of sine x is negative cos. I did not show my work on this one. Let me think about this for a second. I did show my work. It was at the bottom of the page. Okay. The integral of sine is negative cos. Goodness gracious. All right, so this is negative 1 over y. And I went ahead and I used my little trick where you can just switch these places if you want to get this one alone. And so y equals negative 1 over negative cos x plus c. And then I saw that I had 2 negatives, so I kind of canceled them out. And again, remember the plus c doesn't really make a difference. Plus c minus c, it's all the same. It's just saying there's a constant on the end. So the answer for this one is D. All right. On this one, we're doing the same thing, but we have our particular solution because they gave us the ability to solve for our c. So e to the y dy dx equals 2x. It's kind of like they had a differential equation. They already moved the e to the y over for us. So e to the y dy equals 2x dx. And I can go ahead and integrate each side. So the integral of e to the y is still just e to the y. And then the integral of 2x is x squared plus c. And now I need to isolate the y. So the way that I do that is I ln each side. So y equals ln of x squared plus c. And now I can use that initial condition of 1, 2. So I'm going to say that if I plug in 1, I get 2. So 2 equals ln of 1 plus c. And now I have to be able to get that c alone. And so I need to get rid of the ln so I can get inside that parenthesis. So e to the second equals 1 plus c. And I could subtract the 1 over. So c is e to the second minus 1. And now I can go ahead and plug that back in. So my answer is ln of x squared plus e to the second minus 1. And so my answer is B. All right, so we are matching the problem with the slope field. So I didn't really look at this part so much. I suppose you could. What I did is I looked at some of the other stuff. I looked at this part right here. So I said at y equals 0, the slope is undefined. So when the y value is 0, I knew that I needed to see some vertical lines there. When x equals 0, I knew that my slope was going to be 0. And so I knew that where the x value is 0, I needed to see some horizontal lines. And so that helped me narrow down a few. So where y equals 0, I need to see that it's vertical lines all the way across down here, and that's definitely not going to happen on A. On B, those vertical lines kind of could happen. So then I was thinking, all right, what about at X? Do I see horizontal lines? No, I don't, so it's not D. B is a good choice. I can see some horizontal lines at X equals 0. I can see possibly vertical lines at Y equals 0. At E, I could see horizontal lines at X equals 0. And probably not vertical lines there. I don't know that I feel super great about canceling it out just yet. This one, C, definitely not. And that's because I don't have horizontal lines at X equals 0. So that helped me narrow it down quite a bit. Then I was thinking, all right, in the first quadrant, I've got plus, plus, right? And so that means that when I do 4x divided by y, no matter what, my slope is going to be positive there. And that actually helps you narrow it down the rest of the way, because if you look at E, you have got positive and negative slopes. All right, number 4, using Euler's method with a step size of 1/2, what's the estimate for y1? So Euler's method, if you guys remember, was that big chart. So we've got x old, y old, step, our slope, which is the derivative, and the derivative was 4x over y. We got change in x times m plus y old, and then y new. So they gave us the initial condition of 0, 1. So 0, 1, we're using a step size of 1/2. So the next x value is 1/2, and then 1, and y of 1 is what we're solving for. So that means that when we get the 1 here, we're done. And our step size is 1/2. Okay, so the m is 4 times x, so we've got 4 times 0 divided by 1, so that's just 0. So this is 1/2 times 0 plus y old, which is 1. So the new y is 1. So now we've got 4 times 1/2 divided by 1, so that's 2 divided by 1, so this gives us 1/2 times 2 plus 1, and that's 1 plus 1 is 2. So if I plug in 1, I get 2. The answer is B. There's no way around that one. You kind of have to memorize that chart. And I wrote change in x times m. I think we did it as m times change in x. I think I noticed on the answer key I switched those back and forth a few times, but really it doesn't matter because you're multiplying them. So, all right. The particular solution, so this is where we're going to say dy dx was 4x over y. We know we had that initial condition of 0, 1, so now we can go ahead and actually solve this differential equation for the specific solution, yeah, not even general. So I'm going to move my y over to this side, so I've got y dy equals 4x dx, and I'm going to integrate each side. So 1/2 y squared equals 2x squared plus c. And then I have to isolate my y. I'm going to multiply the other side by 2. So y squared equals 4x squared plus 2c, but 2 times a constant is still a constant. And then I'm going to go ahead and square root. Now, technically, we would always have plus minus in front of that square root, but I noticed that in the answer choices, they only use the positive version, so that's okay. And then I can go ahead and use my initial condition. So 1 equals 4 times 0 squared plus c. So 1 equals the square root of c, and that gives me c equals 1. So my equation here is going to be y equals the square root of 4x squared plus 1. So E. All right, for this next one, we get to use a calculator, which is nice because we got some decimal answers there. So it told us to use dy dt, which is ky. And so I remembered that this gives us y equals ce to the kt. That was an equation that we solved and we used a few times. Flashcard might be good for that one. And so it says if there's initially 10,000 cubic feet of water in the tank at 4 hours, 8,000 remains, we want to find that k. So I said y equals 10,000 e to the kt. At first I wanted to put that initial value in, and then I went ahead and plugged in at 4 hours we have 8,000. So now we can say at 4 hours we've got 8,000. So first I divided the 10,000 over and I got 4/5 equals e to the 4k. And then to get to the k, I knew that I need to get rid of the e, so I took the ln of each side. So ln of 4/5 equals 4k. And then I went ahead and divided by 4. And so I got k was approximately negative 0.056. And then if you guys remember, when we use decimals, it's okay to round at the end, it's not okay to round in the middle. So now they're asking us to kind of use this equation and do a little bit more with it. And so for me, that meant I needed to store that decimal as k in my calculator. So now I've got y equals 10,000 e to the k times t, and they're telling us they want to know how much water remains at 8 hours. So I went ahead and I took the t and I plugged 8 in right there. And I'm using the k that I stored on my calculator, and I found that 6,400 is what I had. All right. I will say I got this one wrong because I wasn't reading it very closely. So make sure you read it closely. Population of rabbits in a certain habitat grows according to this differential equation. I did not like how it was written because we didn't really write it like that, so I rewrote it like this. Where t is measured in months and y is measured in hundreds of rabbits. And there were initially 100 rabbits in the habitat. What is the fastest growth rate in rabbits per month that this population exhibits? So fastest growth rate, this is the part I got wrong. Fastest growth rate is dy dt. So they're asking what is the largest dy dt you can find. Okay, so I know that the fastest growth happens when the carrying capacity is at its halfway mark. So I know that 10 is the carrying capacity, c equals 10. I know that c divided by 2 is when it's growing the fastest, so 5. And then I just said, oh, that's in hundreds of rabbits, 500. 500 is the answer, but it's not because they're asking for the fastest growth rate. So now we need to go back and say dy dt evaluated when the population is at 5 would be 5 times 1 minus 5 over 10. Which is 5 times 1/2, so 5 halves, or 2.5. And then you need to take that and multiply that by 100, and you get 250. So you just have to be careful. It wasn't saying when is the population growing the fastest, that would be the t value. It didn't say what is the population when it's growing the fastest. It said what is the fastest growth rate. So got to be careful there to make sure you know what your variables are representing. Okay, so here it says which slope field is giving you that answer. And so, I down here just kind of drew what I expected to see. So I knew that at 10 I would have a horizontal asymptote. I knew at 0 I would have a horizontal asymptote. I knew that at 5 it would be growing the fastest. And if you guys remember, these are logistic functions. They kind of look like that. So that's kind of what I was expecting to see. And then I looked at these answers and I was like, oh, they don't just have the first quadrant. They've got 2 quadrants there. That's kind of confusing because I could not remember for the life of me what the other quadrant was supposed to look like because we never drew it. So what I did is I just, I got rid of the ones that were obviously wrong first. So these are straight lines here, clearly not D. Since they're, I couldn't tell, I was like, I don't think there's a horizontal line here, but this part kind of seemed good to me, so I was like, I don't feel comfortable canceling that one out. In fact, when I looked at it, I was looking for that horizontal line at 0, and I didn't find that in any of them, so that I was like, I'm not going to look at that. I can't look for the horizontal line at 10 because it didn't go up that far. So at this point, I just kind of, I knew that E was a bad answer. And then I was like, now I'm kind of stuck because I don't really feel good about A, B, or C, but I don't have the graph that I would prefer this to look like. And so what I did next is I looked at that initial value, and the initial value was 0, 1. So I looked at 0, 1 on all 3 of these graphs, and I kind of drew where the graph would be going. So at 0, 1 here, and then at 0, 1 here, and then at 0, 1 here. And it was funny because I think up until I drew that initial point, I was kind of feeling like C might be the answer. And then when I looked at this, I was like, oh, that's moving wrong. It's not supposed to it's supposed to go up and kind of level off, and this just kind of goes out. So I narrowed it down. I said no C. So from here to make my final decision, I was just thinking about the difference between these 2 graphs. To me, it kind of made sense over here that I wasn't seeing this horizontal line. Like if you had a few rabbits, it just kind of made sense to me, like, oh, it's growing super fast. They both kind of had that. I liked this one. I could see at 5 we really had this fast growth happening here. On this one I wasn't seeing it as much, and so I didn't like that. I was like, oh, I feel a little bit better about this one. This one to me made a little bit more sense on the left side, and so I kind of made a guess. It felt like an educated guess, and I went with A, and A ended up being right. So you probably could, if you had the time, solve that differential equation, find the specific solution there, and then see which graph it matched. But when you're going quickly to make sure that you have enough time to get through all the problems, this would be a good way to kind of narrow it down, make an educated guess, and spend your time somewhere else. All right, we have another problem with Euler's method, so we're doing that chart again. So I've got x old, y old, and it was with that same problem. So they told us to, we're using the initial condition from the problem, which is 0, 1. And they want us to use a step size of 1, so that's the next problem. And they want us to figure out what we'll get when we plug in 2. Goodness gracious. 2. Okay. So my delta x is 1. So for the first one, I said my slope is going to be 1 times 1 minus 1 over 10. So 1 times 9/10 is 9/10. So I said that's 9/10 times 1 plus y old. And you can use your calculator on this, I believe. Are you still using your calculator? Yes. So 19/10. That's what I got there. And I put that down here. And now for this slope, it says y times 1 minus y over 10. And when I plugged that in, I got 1.539 times my change in x plus my old y. And that gave me 3.439. And then I remembered, so if you plug in 2, this is what you get. This is a y value and your population was in hundreds. So then I took that decimal and I multiplied it by 100 and I got C. All right, now on this one, I was looking at this and I was like, oh no. I know that dy dt, when dy dt equals ky, that's ce to the kt. I was like, ooh, I know that, but I don't know what k over y is. So what I did is I was like, I had to think back to how we got this so that I could take that same approach and do it on this problem. So I was like, well, it's probably doing the separable equations. That's the only way I can think of getting from here to here. And so I did that just to make sure. So I said if I take the y and move it over to the other side, I'm going to say 1 over y dy equals k dt, and then integrate each side. So that gave me ln y equals kt plus c. And then to solve for y, I did e on each side. So y equals e to the kt plus c. And if you guys remember this, we would separate these. So we'd say this is e to the kt times e to the c. And e to a constant is still just a constant overall, and then we moved that to the front. So I was like, okay, I know how we got this now, so now I can apply that on the other side. So dy dt equals k divided by y. So I went ahead and multiplied the y over. Y dy equals k dt. And then I got 1/2 y squared equals kt plus c. And then I multiplied each side by 2. So I got y squared equals 2 kt plus c. And so y equals the square root of 2 kt plus c. So there's my equation that I'm using, and then I need to use my initial condition. Initially there were 5 gallons of water in the tank, so that gives me the 0.05. And then after 3 minutes there were 7 gallons. So if you guys remember in problems like this, it was pretty common for us to have an initial value that helped you figure out what your k value was, and then after that you could actually solve the problem. Alright, so if I plug in 0 for t, then I get 5. So 5 equals the square root of c, and so c equals 25. So then I said y equals, well, that didn't help me get my k, that helped me get my c. 2 kt plus 25. Alright, now I can go through and do this stuff to get my k. Sorry, so this point is what's going to give you your k. Then you can use the 18 minute. So 7 equals square root of 2k times 3 plus 25. And then we'll go ahead and square each side. So 49 equals 6k plus 25. And then I went ahead and I subtracted the 25 over, so I got 24 equals 6k. And divide by 6 and I get k equals 4. So that means now I have y equals 2 times 4 is 8. 8t plus 25, and now I can go ahead and plug the 18 in. So 8 times 18 plus 25, and take the square root of that, and you get 13. All right, so for this one we have dy dx equals 1/2 y times cos x. And they give us an initial value there, so they're helping us solve for c, so we can get the particular solution. And then it asks us some stuff about that particular solution, f of x, and so I knew that I needed to do the separable equations and find our specific solution first thing. So dy dx equals 1/2 y cos x. And I went ahead and only moved the y over, I left the 1/2 on this side. So if I move the y over, I've got 1 over y dy equals 1/2 cos x dx, and then we're integrating each side. And I'm going to go ahead and just leave 1/2 in front of the integral. So this would be ln y equals the integral of cosine, so 1/2 sine x plus c, and then I had to get my y alone, so I did e on each side. So y equals e to the 1/2 sine x plus c, and I went ahead and rewrote this as e to the 1/2 sine x times e to the c, and e to the c, that's just going to stand for your constant. So y equals c e to the 1/2 sine x. And then I went ahead and used that initial value to figure out what my particular solution was. So if you plug in 0, you get 2. Sine of 0 is 0. So this gives us 2 equals ce to the 0 power. And that's just 1. That means 2 equals c. So the equation that I'm dealing with here is y equals 2e to the 1/2 sine x. There's my equation right there. So now I can go ahead and use that to go back and answer some of these questions. So it says that f of x has a vertical tangent. Remember they said y equals f of x. This is our f of x. F of x has a vertical tangent at y equals 0. I know that vertical tangents happen when the derivative is undefined. So I looked at this and I was like, okay, I'm going to need to take the derivative of this. So it's the derivative of e is just e, so it's 2e to the 1/2 sine x times the derivative of the exponent, which is 1/2 cos. And then the 1/2 and the 2 cancel. So our derivative is e to the 1/2 sine x times cos x. So then I was thinking, all right, when is this undefined? And there's no place where that would be undefined. You can, for x, when you plug x into cos, when you plug x into sine, those are defined for as a domain of all real numbers. So I was like, okay, it's not going to be undefined. It has a horizontal tangent when x equals pi halves. So I went ahead and plugged pi halves in. So e to the 1/2 times sine of pi halves times cos of pi halves. So that's e to the 1/2 times sine of pi halves is 1 times cos of pi halves. Cos of pi halves is 0. So that is 0. And so that means that's true. We do have a horizontal tangent because the slope at pi halves is 0. And then third, we want to find the slope of f of x at the point 0, 2 and make sure it's 1. So what I did is I took my derivative and I plugged in the point 0, 2. So if you plug in 0, you get e to the 1/2 of sine 0 times cos 0. So that's e to the 1/2. Sine 0 is just 0. Cos of 0 is 1. So e to the 0 is 1. 1 times 1 is 1. So that's true. So we're choosing an answer with 2 and 3, which is D. And then 13 is kind of nice because they just want the particular solution, which we had to have to do the rest of the problem. And so number 13 is E. All right, 14 and 15. So for 14, they gave us the differential equation, and then they want to know about the particular solution. And so I was like, oh, this is easy. I can go ahead and just solve this differentiable equation and find the particular solution and then just answer the questions about it. Except this is not a separable equation. So that like throws a wrench in your plans a little bit because you can't actually find the solution. So what I did instead is I went ahead and I drew a slope field because I knew that if I could draw the particular solution of the slope field, which I can always do, then I could answer these questions. So I went ahead and I drew the slope field knowing that I was going to draw a solution through 0, -1. So that told me that I needed my slope field to go down a little bit. So here's my y-axis, here's my x-axis. Okay, so then I just started finding some slopes on there. So if I have 0 plus 2 times 0 is 0, so I got a slope of 0 here. 0 plus 2 times -1 is -2. 0 plus 2 times -2, that's -4. -6, so it's steeper there. 0 plus 2 times 1. Okay. And then over here I've got -1 plus 2 times 0, so that's -1. -2 plus 2 times 0, so that's -2. X value of -1. -1 plus 2 times -1 is -3. -2 plus 2 times -1 is -4. -1 plus 2 times -2 is -5. -2 plus 2 times -2 is 6. -1 plus 2 times 1. -2 plus 2 times 1. Maybe let's do some over here. 1 plus 2 times 0. 1 plus 2 times -1. 1 plus 2 times -2. Okay, so if I draw the solution through 0, -1, here's 0, -1 right here, and I can kind of follow this. I'm kind of following that one. Okay, there's my picture. Increasing in concave up, nope. Increasing in concave down, nope. Decreasing in concave up, nope. Decreasing in concave down, yes. Decreasing in linear, nope. So the answer is D. All right, now we're going to use Euler's method. We're getting real good at this chart. So x old, y old, delta x. Oh, man. M equals x plus 2y. So they gave us the initial condition of 0, -1. They want a step size of 1/2. They just want us to plug in 1/2, so that's kind of nice. We only have to do this once. All right, so our slope is x plus 2y. So x plus 2 times -1. So that's 1/2 times -2 plus -1. Oh, this is a new problem. Sorry, I was using the initial condition from 14. This initial condition has 0, +1. All right, so 2 times 1/2 is 1. 1 plus 1 is 2. That was it. All right, so there is all of those. For our free response, no calculator. All right, first question, what is the domain of f of x? I have to say I guessed correctly on this one. I answered part A last when I did this problem, and I was like, is that it? And then it really was right, and then I wouldn't have gotten all the points because I didn't write about it. So for part A, it says, what is the domain of f of x? F of x is literally what you're plugging into the function, right? That's what the domain is if you can plug it in and get numbers for it, it's your domain. So you think about the x, that this is the fundamental theorem of calculus. We're going to be right because I've got those two different variables. And if you think about this x being plugged in here, we want to think about what the domain is of this function, and you're plugging something into a third root. So in a third root, you have a domain of all real numbers. You can plug in negatives, you can plug in positives, and since your x is being plugged in here, that means that you can plug anything in for x as well. So for A, the domain of f of x is all real numbers. And your reasoning behind that is because the third root of t is defined for all real numbers. And since x to the third is being plugged in for that t, then x to the third is going to be all real numbers as well. So your domain is all real numbers. So kind of interesting. All right, for what values of x is f of x equal to 3? So I went ahead and I said 3 equals, and then that's my f of x. And so I just minus 3 because I was like, okay, let me try to solve this and see what happens. And then I had an aha moment because I was like, oh, the only way that these equal 0 is if you do the same number to itself. Is if you evaluate the integral and you say it's 8 to 8, then it has no area underneath the curve, it's just 0. So I was like, oh, that's perfect. X to the third equals 8. I can solve that. So I took the third root and I got x equals 2. All right, so let's make sure we're getting all the points for this. So for part A and part B, they're each 1-point questions. And for A, they kind of gave an explanation as part of this, but I think it just says 1 point for the answer. So I think if you wrote all real numbers, you might have been good there. And then for part B, the answer is the only point you get, so x equals 2. All right, so for part C it says show that f prime of x is 3x squared times f of x. Excuse me. So we need to find f prime of x. So that means we need to take the derivative. So the derivative of 3 is 0 plus, and then when you do the derivative of this part, this is where you use the fundamental theorem of calculus. So we're going to have f of third root of x to the third times 3x squared, right, because we do the derivative of that, minus f of the third root of 8 times the derivative of 8, which is 0. And that part cancels out. So here, our third root and our third cancel out. So f prime of x is 3x squared times f of x. Okay. Oh, and that was it. So the points here, there were 2 points. One for the argument of f of x, and then one for doing the chain rule. So I think the argument was just doing the work, unless that's a vocabulary word I'm not sure of. Either way, this is the only work they showed when they did their answer. All right, and then part D says solve the differential equation to find f of x in terms of x only. So I was like, ooh, differential equation. I need to think of this as dy dx because right now this notation to me does not scream differential equation. So I wrote this as dy dx, and I left that as 3x squared, and I called this y. And then I was like, that's pretty easy, I can do that. So we're going to go ahead and separate this separable equation. So I've got 1 over y dy equals 3x squared dx. And so this is, and we're integrating each side. So this is ln y equals x to the third plus c. And then we're going to go ahead and solve for y. So I'm going to take e on each side. So y equals e to the x to the third plus c. And what I did is I said, okay, that's y equals ce x to the third. And I was like, ooh, I'm done. Except when I looked at the answer key, I was not done. And that's because we know that we have this point. We have some information there. We know that when x equals 2, the f of 2 equals 8. And that is because of the work we did in part B. So you had to go back and solve for your c using that information. And so over here we're going to say 8 equals ce to the 2 to the third. 8 equals ce to the 8th. So I'm going to divide by e to the 8th. So c equals, I'm going to write 8e to the negative 8, like that. Okay. And then we can go ahead and write down what we have. So we have y equals c, which was 8e to the negative 8, times e to the x to the third. And we can add these exponents together. So y equals 8e x to the third minus 8, which is the answer. So I would not have gotten full points on that. So part D is worth 5 points. You get 1 point for separating your variables, 1 point for taking the correct antiderivatives, 1 point for including your constant when you do the integration, and then the last point, oh sorry, did I say 2 points for the antiderivatives? I can't remember. And then 1 point if you solve for your constant correctly. So with all that said and done, I would have got 8 out of the 9 points. Not terrible.